NX has a strength in CAD, then tighter integration with the CAE. It's got a lot of CAE capability, and one of the strengths that we brought in is to do the cavity meshing, which has been always a tough challenge.
Very often analysts don't have the underlying geometry, they just have a mesh-based representation. But now you can also take in meshes rather than just geometry. So that's a big step forward, because you need not have the underlying geometry, which is very often the case. And so you can just start off with a, say, an S-strand mesh, an orphan mesh with no underlying geometry, and you can create the internal fluidic cavity out of there, just as you would with regular geometries. And this would let us move into domains beyond CFD, like acoustics, for instance, where these kinds of rapid creation of fluid domain will be highly beneficial.
We incorporated bringing in data from the test, simulation and test. What we have is a load recipe that we have. And the load recipe is essentially you bring in test data, and then you bring in the loads, displacement, velocity and acceleration, and apply it to the FE model. We actually support the panel and mold contributions now in NX. So the post-processing capability has that panel and mold contributions. It's going to give you all the results from master. Typically automotive use cases is that one would be interested in looking at the response of different panels or the contribution from a different panel at a given location. So there's a response point, and or you can at least, if the panel is contributing more, then you could actually reduce it. There are applications like, you could do architectural acoustics, where you could be studying, a room like this, where, a speaker is giving a lecture. Second, it's also there in the aerospace industry. It's an automotive industry, it's very widely used. And then our software also gets used in designing loudspeakers. It kind of formalizes the acoustic support, so it's almost like a new physics environment in NX.